So let's break down elements more. So we talk about elements, right? An element is a substance that cannot be decomposed further by chemical means. All right. So these are the building blocks of matter. We can't break them down in a lab. All right. This was, it's just something we can't do. All right. Each element has a symbol, which is one or two letters derived from its name. So it's always going to be capital letter, lowercase letter. Very important. This is very important. All right, because again, when we write down, we're communicating. Okay, we need to communicate. So everything written needs to be something we can read and communicate with. All right. Now again, I don't have the best writing anymore, but you still need to be able to tell. And so, for example, I've seen CN, which is a compound now, or I believe that's one of the new elements. CN versus I've seen this written down versus CN. Alright? Or CO versus CO. Right? If you look at this, make sure we use our capital letters for capital and lowercase for lowercase, right? Like this first one, this is cobalt metal. So if I told you there was 2 kilograms of cobalt metal in your room, that would be fine. It would just be sitting there, not that big, whatnot. This is carbon monoxide. If you had 2 kilograms of carbon monoxide in your space, that might be very dangerous, right? Because carbon monoxide binds to your hemoglobin and stops your oxygen transport from happening, so it basically suffocates you. Big difference. So you got it like, oh, I didn't realize. It's a huge difference. It's a huge deal. So we got to make sure we do this correctly. This is not, right? Because if you communicate to me that danger cobalt's present, I might not know why that's dangerous. If you say danger carbon monoxide could be present, all of a sudden now I know why it's dangerous. All right, and so it's just a communication. But you got to be clear on how you communicate. All right, so the smallest particle of an element is called an atom. Smallest particle of an element is called the atom. All right. Now, some elements exist as molecules. Right? And a molecule is a small, discrete unit of atoms bonded together. All right, it's a small, discrete unit of atoms bonded together. It's a small group. Like one you know is H2O, right? Water. That's one oxygen atom, two hydrogen atoms. It's really close, right? Now, some of these elements that are molecules would be like S8, sulfur, sometimes P4, right? You don't need to know those. There are 7 elements that exist as diatomics. Of course, that's H2, N2, O2, F2, Cl2, Br2, and I2. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So, it's good to know those. All right. Okay. Now, I want you to point out to note that some elements, right? Some element symbols, okay, are derived from names that are not English. All right. So we have sodium, which is Na, and that's natrium. We have potassium, calcium. Right? Now, do you need to know calcium and natrium? No, that's just where they came from. We need to know sodium, potassium, iron. All right, iron is Fe, and that's ferrium. No, there's no I. We got copper, which is Cu. That one kind of makes sense, but it's Cu for copper, but it's cuprum. You get silver. Ag is silver, and that's argentum. Got gold, Au, and that's Aurum, aurum. Then you have tungsten, W, wolfram. Tin, Sn, right? And that's stanium. All right. We got 3 more. Antimony. I'm going to come over here. Antimony, lead, and mercury. Antimony is Sb, lead is Pb, and mercury is Hg. So Sb stands for stibium, Stibium. Lead is plumbum. And mercury is this word. It's like hydrium. I don't know how to say that. I really don't know how to say that. You don't have to either. We call it mercury. Right? So those are the elements, and those are the fun ones that do not make sense by looking at their name. Right? A lot of the other ones make total sense. If I tell you if I tell you tantalum, you can probably find Ta and figure out it's number 73. But if I tell you tungsten, you'll be looking a long time. You never find that it's W, because how would you get W from tungsten, right? So that's where we use these. That's why we get now, a lot of periodic tables now have the names, but just in case they don't. All right, let's talk about compounds now. Oh, there we go. So when we talk about compounds, this is a combination of elements. We will use 2 main groups. We'll have molecular. And we'll have ionic. Alright. So, molecular, these ones are above the stairs and hydrogen, nonmetals. Ionic would be opposite sides of the stairs. What are the stairs? So if we look at a periodic table, there's my periodic table. And yes, it doesn't look quite like that, right? There is another box here, right? And then there's one there, and then there's there and there, right? The stairs actually go this way, right? And so you got boron and aluminum, Al, and it's between boron and aluminum, and all these again are the non-metals, right? And H is also a non-metal. So that's above the stairs and hydrogen. When those combine, it's going to be a molecular compound. When we have a metal and non-metal, right? Group 1, group 2, all like these are the metals. The metals, even down here, are the metals too. Those are metals. All these are metals. All right, even underneath the stairs are metals. Right? Those are going to be ionic compounds. So we have metals and non-metals opposite those stairs. All right, so it goes between boron and aluminum, and it's just stairs next to aluminum down. So next to between silicon and germanium, arsenic and antimony, tellurium, polonium. Those are the stairs. Okay. Now, each compound has a formula indicating the composition of the compound. So there's a formula. All right, so let's look at some of these formulas. All right, and so some formulas would be like H2O, CO2, CH4, NaCl, CuNO3, 2. All right. So now if we look at these, it's always going to be a good idea to have a periodic table handy. Okay. Now, can you have one on the web? Sure. And I don't have it saved on this. All right. Let's do. Nope. I had to delete a YouTube video. All right. Periodic table. There we go. Dynamic one's good, right? Web elements is good. All these are good tables. Okay. All right. These are all the P table is good. That actually gives you a lot of information. Maybe we'll go to that one. There we go. All right. Okay, and this is fine. Okay, it tells you the names. It gives you all this stuff. Tells you the states. Right. The stairs are right here. All right. That's the stairs. Okay. So you have these metalloids. It's kind of down below. It's below boron, silicon, arsenic, tellurium, and acetine or acetine. So opposite sides, you're going to be metallic or ionic, opposite sides. And then hydrogen counts as a non-metal. It's over here, as we'll learn why soon. But it's also over. Some periodic tables have it next to helium too. sometimes some periodic table will have hydrogen, helium on both group 1 and 2 and 17 and 18, just because. All right, so it's always good to have a periodic table. This is one. There's any of them. You can print one off. The one I gave you, they're all fine. All right, so if we go back here, water. All right, that's the common name, water. CO2, that's carbon dioxide, and common name of methane. And if you look at your periodic table, hydrogen counts above the stairs, carbon's above the stairs, oxygen's above the stairs, right? And so these are all going to be molecular. Sodium chloride. And then you have copper 2 nitrate. And these are going to be ionic. And first of all, I want you to notice something. Note, all ionic compounds are considered salts. So it's not just salt, they're both salts. That's sodium chloride, that's a salt. Copper 2 nitrate is a salt. So any ionic compound is technically a salt. Table salt refers to sodium chloride. Just like sea salt, a little bit different. Okay? And so those are all ionic compounds. All salts are ionic compounds. Alright?